Given that BP is the perpendicular bisector of AC and CP is the perpendicular bisector of BD, and PS here is congruent to PR there, so these little segments here, which of the following statements is not necessarily true? Alright, so triangle ABC and triangle BCD are isosceles. Well, let's see here. So it's a little complicated because there's so many overlapping lines, but let's try to visualize just this segment here. So this is a line segment, and this here is the perpendicular bisector of this line segment, which means that these two pieces here, this piece and this piece, are congruent, and also this line and this line are congruent to each other, because if you have a perpendicular bisector and you have a point B on that perpendicular bisector, then if you draw lines from the endpoints, you know that these lines are also congruent. They have equal length. So, because if you think of this as being the triangle ABC, ABC's here, and because these two lines here have equal length, that means that this is an isosceles triangle. Now, we also have triangle BCD. All of the same concepts apply to this triangle here, because we know that this line here is the perpendicular bisector of this line that has endpoints B and D. Therefore, the lines from B to C will be congruent to the line from D to C, making this also an isosceles triangle. So these are true. Moving on, AB equals CD. AB equals CD. Well, here we have this length, which is equal to this length, and because this is also an isosceles triangle over here, we know that this length is equal to this length over here, so this line is also congruent to the first line. So that is true because of the congruent segments definition. So because they're congruent segments, they all have equal length. All right, finally, we have BP is an angle bisector of triangle ABC. So BP here is the angle bisector. So picture that like a ray going right down, cutting this vertex angle of this triangle into equal pieces. This is true. So when you have these two, so picture this whole big triangle here, ABC, and then we have this perpendicular bisector that hits this vertex. These are all, this triangle here, this half in purple, is congruent to this other half here. Therefore, these angles are the congruent corresponding angles, so this is also true. So the answer to this problem is D. All of the statements are true. There we go.